Hello everyone. For this tutorial video I like to talk about parallel circuits, which are actually more commonly used than series circuits, like in electrical wiring in your house, or how chains of light bulbs work. And there's actually a logical reason why parallel circuits are more widely used than series circuits, which I will explain in this video. Using the plumbing/sewage system analogy, like I did for series circuits, you may already be familiar with the fact that the pressure drop at different pipes in the system is the same, regardless of the resistance of the pipe itself. So this should carry over to parallel circuits as well, where the pressure drop is obviously a voltage, and the electrical current is analogous to the flow rate of the water. Like with the schematics involving series circuits, the voltage is usually given to you by the voltage source itself, and the resistance is usually given to you by a color code on simple resistors, or by a resistance rating if you have something like a light bulb. So the current is actually easier to calculate in parallel circuits, because we are given a measured voltage and measured resistance, and we know the voltage is the same regardless of the resistance in a parallel circuit. So we simply divide the voltage by the resistance for each resistor to get the current flowing through one resistor. And then we should see logically that the total current in a parallel circuit is a simple addition of the currents of each individual resistor, which should make intuitive sense, because current does not magically start up or go away, so there must logically be a conservation of current in order for the circuit to work. An interesting thing about resistance in a parallel circuit, and the reason why parallel circuits are so useful, is that the total resistance is actually less than any one of the individual resistances, and the calculation used to predict the total resistance is 1 over R1 plus 1 over R2 plus 1 over R3, etc., but then 1 over your result. And you will often see that 1 over resistance is also called conductance, as a reference to how well something conducts electricity, which has the unit Siemens after the physicist who discovered it, exactly like the reason why volts are given their name and ohms are given their name. So you can make the formula simpler if you know that 1 over R is the conductance. So you can state the total conductance is a summation of the individual conductances. Although series and parallel are the most basic types of circuits, most circuits you see in electronic devices, or even in other applications like wiring systems for schools or homes, are much more complicated than just either series or parallel, and is usually more than not a combination of both at the same time. And this is appropriately called a series parallel circuit, and so I will explain the basic schematic of how it works in the next video, and then give more in-depth explanations of different theories used to analyze them, like how to use the fact that powers add, or something known as Kirchhoff's laws, in order to predict voltage, current, and resistance at a particular point in the circuit. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.